Welcome, everyone, and thank you for joining us. I'm Brenda Dettinger from BIOPAC, and I will be your moderator on today's webinar, Advanced Wearables, Capturing ECG and Heart Rate Variability with the Research Ring. Today's webinar is being recorded, and we'll send each of you a link once that recording is processed. During the webinar, if you have questions, please submit them through the GoToWebinar control panel. That's how you communicate with me, your moderator, and I'll pass questions on as I can. Now on to our presenters. I'm really excited to introduce our experts today. We have Dr. Hugh Lusted. He is a PhD and founding partner at SendStream Inc. He earned his PhD in neuroscience at Stanford University School of Medicine in 1980 and has since focused on developing high quality portable biosignal acquisition systems. Welcome, Hugh.
Hi, everyone. Thanks for being here.
All right. We also have Fraser Finlay. He is the CEO of BIOPAC. He has over 25 years of experience in the life sciences and physiology monitoring industry. Fraser oversees the development of physiological data collection and analysis products and is a well-regarded expert who presents at workshops all over the world. Welcome, Fraser.
Thanks, Brenda. Welcome, everyone.
All right, Fraser, let's start with you. I'm making you presenter.
Okie dokie. Okay, welcome everyone, and thank you for joining us today. Brenda, thank you for the great introduction. Before we start, I have a little background information about BIOPAC. BIOPAC develops high-quality scientific tools that allows you to measure physiology anytime, anywhere, with any subject. We've been in business for over 30 years, and 99% of the top 100 universities use BIOPAC products. And many of the largest technology companies use our products for development and validation. All those customers have helped to create over 56,000 citations for BIOPAC. Okay, so we're talking about the research ring today, so I figured I would just start by showing you the ring on screen and giving you an idea of the differences between the latest version and the original. So this is the latest version right here. Hopefully everyone can see that okay. The addition of the snap fastener on the bottom allows us to collect continuous ECG data. So a little snap fit electrode lead connects onto the end, and from there the other end is connected to an electrode on the other side of the body. So I will wear this ring on my left hand, and on the right side I have a disposable electrode. And we'll get into the details as we move on. Here's the current shipping version, and if you notice on the back side there is a gold electrode. On the new version, we tap into that and add this little snap stud fastener. And this is optional. This can be removed. So the ring by default will look a little bit like this. And if you add the kit for continuous ECG, you can screw this little fastener in. All right, that kind of gives you a little bit of an overview of the ring. Then in terms of the data, it looks something like this. So when we talk about multimodal signals from a single ring, you're able to get a lot of data out of it. The top channel is the count. So this gives you an optional continuous count of the data that's coming for the time and the data that's being transmitted, so you can see if you're dropping data. This is the ECG. This is raw ECG coming from the electrode lead. Beneath that, we've got pulse, and then electrodermal activity, and then there are 3 channels of accelerometry data, X, Y, and Z. And then I've got a couple of calculation channels. Oh, I beg your pardon, I missed that. Temperature, and then X, Y, and Z. And then I've got a filtered ECG waveform down here. So it's basically, this is the raw, and then this is filtered. And then down below, I've got a heart rate channel. Okay, so that kind of gives you a quick show and tell of the ring itself. Let's move this out the way for a moment. And get back to my PowerPoint. Here we go. Okay, so as I just mentioned, the ring is multimodal. EDA, pulse, temperature, ECG, and then through an IMU we get accelerometry data as well. The ring communicates with a phone, iPhone, iPad, or a laptop computer running AcqKnowledge via Bluetooth. One of the nice things about the communication protocol is that you can run up to 9 rings simultaneously to a single device. So for those of you that are interested in using the device with multiple participants in the same location, you can have 9 rings talking to a single laptop computer. And then you can have multiple laptops in the room as well. So blocks of 9, providing you're using an Intel Bluetooth adapter. And I'll get into a little bit more of that in a moment when I show you what that looks like inside AcqKnowledge software. With the current and original design of the ring, the gold electrode that I showed you on the back of the ring, you had to contact that electrode to the skin on the other side of the body. So it was sort of a temporary way of getting an ECG waveform. And you just hold the ring a little bit like this on the other side of the body, and you'll start to see an ECG waveform appear on the display. Obviously, that's not that convenient for people that want to do longer term recordings, and particularly if you've got remote participants that are trying to perform different tasks and go about their life. With the addition of the ECG lead, you now have the option to record continuously, and then that opens the door for heart rate variability type studies. The ring uses dry electrodes, but I find that if I just add a small amount of gel, almost like a moisturizer around the finger, that definitely helps with the signal quality. And if you're interested in EDA, you can add just a small amount of our gel 101, and that helps clean everything up. So at this point, I'm going to give you a quick demo of the ring itself, and then I'm going to hand over. Actually, I'm going to hand over to Hugh right now, and Hugh can give a walkthrough of the ring with the iPhone application. So, Hugh, I'm going to hand over to you.
Great. Okay. And let's get our little full screen going. Thanks, Fraser. That was really nice overview. Good reminder about some of the ring features. So what I'm going to talk about now is the functionality of the data streaming from the ring. And I'll show you some screenshots from the app. the iOS app and also from our SendStream cloud. Once you upload your data, the cloud displays are very good for screening the data quickly. So the ring comes fully charged out of the box, and you can download the SendStream app from the Apple uh, store. And um, basically, actually, I want to mention one of our users said they were up and running, actually recording data in 3 minutes. So I haven't actually timed it, taking out of the box, launching the app, and finding the ring. The ring will advertise with its little blue flashing light and show up on the screen. And you basically can start a session once well, you might first want to log into our SendStream cloud account with your email, and then you can either start recording on the ring itself locally, or you can connect to the cloud, and as soon as you finish the session, it will upload the data for you. So once you start a session, you have a choice of what to display during the session. So you can display all the raw data channels as well as derived signals like heart rate variability, and RSA for both PPG and ECG. So today we're focusing on the continuous ECG, but I just wanted to mention there are all these other channels that are available for your studies. So let's take a look at some of those screens. You can just display raw data if you want, like the screen on the left, or everything, which scrolls way down. There's so much there you can't really use it all in real time, but at least you can use this feature for screening your data quality, which is really important to see your live signals. So this is what it looks like when streaming by. And this is, there's PPG at the top, ECG there, and this is ECG using the new ring with the external electrode. EDA in blue, and then just, I don't have room for more on one screen, but there's temperature at the bottom, slowly increasing for this particular use case. Um, Wanted to mention that as you can see in the PPG and the ECG, the peak picker is running in real time, and it can calculate the difference between the ECG peak and the PPG peak to get a pulse transit time or a pulse arrival time. We'll talk more about that later. And also you can flip the phone to horizontal. This would be when you're reviewing the data after the session. And you can zoom in with this feature at the top. You can zoom in all the way to a particular waveform if you want. And again, this is a screening feature that you can look to see if there were motion artifacts, how bad they were, how severe they were, for instance. And let's see, I think. Oh yes, I have one more little demo here of this is again the actual ECG waveform, a little recording we did from a user that's just, this would be normal activity, maybe moving around a bit, maybe working at the computer. And so you will see some fluctuation in the baseline, but generally speaking, the PQRST wave complex is well rendered, and even though there's a bit of motion there, even with that baseline trending up and down, the signal quality is still very good. And as Fraser's going to show you, it's easy to filter some of this noise out in post. So I think, let's see, yeah, that's what I have for now.
Okay, I'm going to walk through some of the details of the ring. There's a lot of technology built into it, particularly for such a small device. So on the inside, you've got dry electrodermal activity electrodes. So this is the bottom of the ring. This is the point where it's making contact. If I hold this ring up, you can see hopefully just about there, you can see the electrodes just inside. So that's the electrodermal activity. And then in terms of data quality, because I know this is important for a lot of people, we've validated this. We had a group at UCSB, they did a comparison of the research ring with our Bionomatics wireless electrodermal activity device. And the comparison was very, very favorable. In fact, the correlation coefficient, when we look at the waveforms across the two devices, is actually 0.96. So it's very good. I mean, the quality is excellent. You've also got a pulse sensor in there, an optical pulse sensor, and you get nice waveforms from that. The only problem with the pulse is it is motion sensitive, so moving around a lot, you do get artifact in there with that. And then the internal ECG electrode. So again, if I hold the ring up, hopefully you can see that just on the sides, the furthest side, you've got these two ECG electrodes, which are shown in the diagram here, and then where we're adding the new contact point is just here. So this is the stud on the back, electrode lead out to a disposable electrode to give you continuous ECG. There's an IMU built into the top of the ring, and that's where the battery is housed. And then in terms of battery life, you're going to get about 10 hours of continuous streaming, which is pretty decent for most applications. In terms of the data you get from the device when you're using AcqKnowledge, you'll get the X, Y, and Z signals from the accelerometer or from the IMU. Now this is the point that Brenda was talking about. The ring is one size fits all, but there is a really nice shim that just slides in to a couple of channels like so, and that allows you to resize the ring. So the ring can accommodate American standard ring sizes 13 through to the smallest size 6, but Hugh has a trick that he has come up with for reducing the size. He removes all the shims, and he uses one of those rubber earplugs as a sort of padding to hold the electrodes close to the finger. So if you're really going down to young kids as young as 2, you can do that by filling this sort of gap up the top with a foam earplug. But otherwise, the ring itself goes from size 6 to size 13. Size 13 is without a shim, size 6 with the largest shim, and each ring comes with a pack of these shims. So for sizing a participant, it's very easy. It's you kind of eyeball the finger, you get used to relative sizes, you can slip a shim in quite quickly and place it over the finger. In terms of charging, the system comes with a USB charger. So when one end has a USB-A connector, the other end has this barrel, and the ring connects to the barrel. It's slightly magnetic, and the LED inside the ring changes color based on the level of charging. Fully charged, it's a bright green color. Okay, so let's take a quick look at the system in use in AcqKnowledge. I'm gonna make some changes here. Change my screen. Okay, so if I bring up AcqKnowledge, so this is a template file that I've already got set up just to make life a little bit easier. AcqKnowledge lets you know the ring that you're connected to. This menu here is our hardware menu. So if you're familiar with our software, you may have an MP150, MP160, MP200, or some other hardware device. This menu always takes on the hardware, the name of the hardware that you're connecting to. If we go into setup data and acquisition, we get to see a display like this where we get a view of the battery level. There's a handy little tool. So if you've got a lot of rings and you're trying to identify the one that you want to use for a participant, you can click identify, and if I hold my finger up to the camera and do that again, you should see the LED blinking inside the ring. So super handy for that. You can reconnect. So if you've lost connection or you haven't connected, this is going to give you a reconnect via Bluetooth. You can power the ring off from inside the software, but more importantly, you can determine the signals that you want to record. By holding this menu down, we've got different combinations. So if you only care about ECG and heart rate variability, there's an option here. You get ECG at 800 hertz. So for those of you that are really purely interested in HRV, it's a nice option for you. But for those of you that are interested in the multimodal nature of the ring, then you've got different options: ECG, pulse, and EDA, or ECG, pulse, EDA, and temperature. Different combinations, different sample rates. I've got this set up so that we're recording ECG and pulse at 400 hertz, EDA at 20, and temperature at 20. And then I've enabled down below the accelerometer channels as well. Now, with the same with our other software, you've also got the ability to add calculations. So I've added a filter to the raw ECG, and then I've got a calculation for heart rate. If we close out and hit start, in a second, we'll start to see data scrolling across the screen. Be a little patient here. And actually, what I'm going to do is zoom in and auto scale. So there we go. This is coming live straight off of my body. I can turn off some of these signals. I'm not too fussed about these. If I auto scale the EDA. So this is the filtered ECG is the red channel, my heart rate at the very bottom. And then I left this count channel on as well. So this is giving me a count of the samples that are coming in. So pretty easy to set up, place the ring on, and very quickly you've got the data coming across. Okay, I'm going to leave that there for the moment. We'll get into the software in a little more detail. I'm going to hand you back over to Brenda for our next poll.
Okay, it's very exciting over here in the Q&A. I've asked Jojo to help answer some questions. While I'm launching this poll here, let's see. Yeah, lots of people are asking about pricing. I'm just going to let you know the best way for you to get pricing is to reach out to your local sales representative, by that form, and I'll show that form again at the end. They can get a quote ready for you. Let's see here. Okay, so I was just trying to find the right question. All right. So Lawrence, a few people actually, Lawrence, Ira, a few other people have asked about how the data is downloaded and stored. Can you export it? You know, what format? What's the storage capacity? That sort of thing. Can you? I'm going to go ahead and close the poll here. 91% of people, by the way, say that ECG, continuous ECG, is important to their research. So I'll go ahead and end that poll. And do you want to address that question now, Fraser?
Yeah, I mean, if you're using AcqKnowledge, it's really easy to export the data out from our Save As option here. You've got a whole slew of different formats. If you're interested in getting it into MATLAB, you've got our own AcqKnowledge binary file format, and we've got an API for that. You can get all the way down, lowest common denominator being text. You can select areas of data and just save those. You can export just chunks of data. There's all manner of ways of getting it out of there. Bringing the data in from the ring itself, there's a couple of options there. The ring can either be saved locally on the phone or it can be pushed to the cloud. We've got an import feature which I'm going to demonstrate in a moment. So import, and then down here from the research ring, we can import a session archive, and this is downloaded from SendStream. It brings all the data in. So it's super convenient to get data in and to get data out. So hopefully that answered the question.
Okay, great. We'll keep trying to answer your questions in the background here, everyone. Now, Fraser, we go back to you, right?
Yes, you do.
All right, there you go.
Thanks, Brenda. Okay, so I'm going to actually change monitors again, so bear with me 1 second. Here we go. Okay. All right, so let's talk about heart rate variability, because clearly there's a lot of people interested in doing this. So heart rate variability is a measure really of the difference from one R wave to the next of the ECG signal. And within the AcqKnowledge software, you've got different tools for performing the types of analysis: time domain, frequency domain, and then Poincare plot for non-linear analysis. The most important part to HRV analysis really is making sure that you've got a nice clean HRV tachograph, which is the display of the intervals from one R wave to the next. Once you've got that, the analysis becomes reasonably straightforward. But in terms of, the importance of HRV and why it's valuable, I mean, it's a great tool for assessing overall health of an individual, identifying potential health risks, monitoring the effects of lifestyle changes, monitoring stress levels, improving fitness, enhancing fitness, optimizing training regimens. There's a whole slew of benefits to the analysis, or advantages to doing the analysis. So it's one of the reasons why it's so popular. Okay, so starting off with the time domain, within AcqKnowledge, there's the ability to perform the time domain. This looks at the standard deviation of the intervals that I talked about, and this reflects the overall HRV and is a general marker for autonomic function. So higher SDNN values indicate greater variability, usually associated with better cardiovascular health. And then RMSSD, which is the root mean square of the successive differences, that reflects the short-term HRV and is a reliable marker for parasympathetic or vagal activity. So again, I'll show you these tools in a moment. And then the frequency analysis, there's a couple of different ways in which you can do this. You can select an area of data and perform what we would call a single epoch, or you can do multi-epoch across the data set. And from there, you get the low frequency, high frequency, and then the ratios between low and high frequency. You know, just a reminder of what it is we're looking at. Sympathetic, parasympathetic, nervous system, kind of, is the person relaxed on the parasympathetic side, or are they more in that fight or flight on the sympathetic side of it? So that kind of gives a quick overview. Point care, XY plot of the R2R tachygram. Okay, I'm going to switch back over to AcqKnowledge and let's take a look at some of these things. I'm going to change my monitor again, so bear with me. Alrighty. And I'm going to make sure that we're starting at the appropriate point. Okay, so if you're starting with AcqKnowledge, I can just come in and open up an existing file. So these are files that have been recently opened, or I can go to a specific folder and open something up. This was the data that I just had on display that I was showing you earlier. So in terms of the features and controls within AcqKnowledge, under the transform menu, you've got options for filtering the data and conditioning it. Under the analysis menu, you've got all the controls down here for things like heart rate variability, or if you're doing electrodermal analysis, you can perform the analysis all within AcqKnowledge. I showed a moment ago that you can bring in data from a session that's been recorded in the cloud. So you download from the cloud. There's an option here, import research. This is a session that was recorded in the cloud, and I can open that up. Now it's brought in the data that was collected. So Hugh gave me this file the other day. This is some data that he had collected. On the top 3 channels, we've got the accelerometry information, and down below, we've got the signal coming in from the electrode. Okay, so easy to bring that data in. Close that one out. But once we've got the data in, or we've recorded the data, you can then go in and perform these different types of analyses that I was talking about. And the important thing, if I turn some of these channels off, I'm just putting clicking on the Alt key on the keyboard and clicking on the channel number, and that will close any channels that I want to remove from my display. I'm going to close this one. So this is the raw ECG. Now, when you're preparing the data for any kind of analysis, you kind of want to make sure that you've got a nice, good, clean signal. This data is unfiltered, so a lot of times you want to come in and clean this up so that you've got a nice, clean signal. So the way I do that, I come in and I say, okay, I want to duplicate this waveform. So now I've got two waveforms. I can then select all, so Control A, come into the transform menu, and I can run a bandpass filter over the data, and I'm going to say, okay, I want to run this from 0.5 hertz to, let's say, 30 hertz, and we'll select OK. Now if I auto scale this, now I've got a clean ECG waveform. Okay. You can then come in and identify or create a tachogram, and the software will do a lot of that for you. This data file here, you've got a reasonable amount of data. There are some things that I can do to clean this up and automate this. If I want to just go in and do the analysis right away, I can do that. But I want to show you how we can clean up and automate some of this. Down below, this waveform down here is the heart rate. So you can see the change in heart rate over time. Using workflow, I come into the workflow editor. I can open a workflow that I've created. I've got one here. This is a workflow specifically for the data file for Hue. So I'm going to open that up. And this is a series of commands that the system will perform in an automated fashion. It will take the open graph, it will select all the data within the graph, and then it will change the active channel to make sure that I'm actually working with the active channel. It's going to duplicate just as I did just then. It will run a bandpass filter, will auto scale. It's going to duplicate the active channel, and then it's going to use a 1 point difference. And what I'm going to do is I'm just going to open that file up and I'll run it. So let me close this out. Come back into AcqKnowledge. I'm just going to open that file up again. Close it out. So let's go back in and import that file that Hugh sent me. So here it is. Okay, and then if I open that workflow again, because I closed it out, here it is. All right, so now we've got these two things. I've got the workflow ready to go. All I have to do is select run the workflow, and I'm going to move that onto my other monitor, and then over here we'll see the results of the workflow. All right. So if I auto scale this, so what I've done here is I've filtered the ECG waveform. I've used a difference calculation, and then I've asked the software to identify the peak of my R waves, the QRS, and it's labeled it for me. Now, in addition to that, I've created another channel which provides me with a tachogram. And the reason I want to do that is so that I have an indication of any areas that I should be concerned with. So obviously, this is non-physiological. This signal is not bouncing around because my heart or Hugh's heart rate bounced around. It's because there's some artifact in there. Now, using the tool up here, this tool here, I can just come in and I can remove that. Okay, so now this artifact here will not be included in my HRV analysis. And I can come through across, and there are a couple of others. Actually, let me just auto scale it and zoom back in. We'll have a look at these other points. Here's another one. And we can see, looks like this is artifact here. You can see it up here. And all I'm going to do is zap that with my tool and come back. It's a little bit over here. Again, I'm just going to zoom in, take a look. You can see, not quite sure what's happened there. Yeah, I'm not sure about that one. That's open to interpretation. I'm not sure if this is QRS somehow, but I'm going to assume that it is. Using the event marker tool, I can come in here and I can add a marker in that area. So I'm going to say, okay, I'll put a QRS at this point here. And now that will take care of that. I mean, some of this is a little bit subjective. That's why it's super helpful to have a visual indicator like this, where you can come in and get a good look at the data and make sure that things are actually making sense. There's something here also. I'm going to do the same here. Put that there. And got one more that I haven't done. And it looks like we've got, there you go, we've got an extra couple in here. So I'm going to take that out and that out. And now, you know, I've cleaned this up and I'm ready to do my analysis. Now I can do that a number of different ways. I can come in here and I can say, okay, I just want to get the heart rate variability. Come in, HRV, this is going, I'm going to do a single epoch spectral over that selected area. You can do the entire wave or just the selected area. I'm going to do it events, the peak of the QRS. These are the events that I've got in here. And I select OK. And now I've got this power in the very low, the high, the very high, and I've got my ratios just for this selected area of data. I can copy that into a clipboard or put it wherever I want. So that's one way. That's sort of a manual way of doing it. Another way you can do it is if you want to do a sort of a multi-epoch. So I'm going to place my cursor here in the recording, come into analysis, come down to HRV, and we've got this option here, multi-epoch spectral. There's a preset, a human adult, and I pick the channel that I want to do the analysis over. So here, I'm going to pick channel 6, and I'm going to do a periodic time interval, and I'm going to say, okay, I want to do this every 60 seconds from where the cursor is located. And I don't want any interval between the 60 seconds. and I'm going to output my results to Excel. And I can put event markers in to show the points where the 60 seconds occur. I hit OK. So now for each 60-second epoch, I've got the very low, the high, the ratios, everything in Excel. I've also got the event markers showing where those 60-second boundaries occurred. So a very quick and easy way of doing that. The other method is to do the same again. This time I'm going to place my cursor right here, come into analysis, and this time I can do statistical. I can do fixed time interval. I'll do the same 60 seconds. And I'm going to do it from the point where the cursor is located, push my results out into the spreadsheet, and hit go. All right. So now we've got, again, the 60-second epochs, and I've got, actually, that's not right. Let's, let's redo that. One thing, make sure you've got the correct channel selected, because I didn't there, because there's no way Hugh's heart rate was 274 beats a minute. So let's just try that once more. Statistical, 60 seconds from the place in the cursor, and we need to make sure that we're selecting channel 6, and we select OK. All right, now this makes much more sense. Hugh's heart rate, his mean heart rate, 84, 85, 88 across the 60-second intervals. We've got the root mean square, the standard deviation of the successive differences, and then the percentage of PNN greater than 50%, and then the actual number that were above the 50% change, and then the standard deviation of the successive RR intervals. So quick and easy to get these analysis, get the results out of there. There's some other options that I want to show as well, because this is a really helpful tool. If you've got like several hours of data, the likelihood is there are going to be segments that you don't want to analyze. There's too much artifact. It's just not worth your while to go in there and clean it up. So what you can do is you can come in and say, okay, like here's a really nice area of data. I want to include that in my analysis. AcqKnowledge has some tools called focus areas. We've got focus area bar and focus areas. And over here, we can come in and create a focus area. And I'm going to call this test 1, very original. And we've created this focus area, and I can come over here and say, okay, I'll call this test 2. So now when we come in and do our analysis, let's say I'm going to do that statistical one again. I can select focus areas. So it will run the analysis just across those focus areas. Make sure I've selected channel 6 again. It's going to spit it out to the spreadsheet. I hit OK. In a second, it will open up Excel with those results. There we go. So these are the two segments, and these are the results for those two focus areas. The same also applies for the frequency, spectral frequency analysis as well. If we come in there, when we come under the multi-epoch spectral, again, we've got the ability to select focus areas. We can pick intervals around events. So if you've placed event marks during a recording, you can select those. Time between event boundaries is pretty flexible. It gives you a lot of options. So a lot of tools there. The important thing is to make sure that you've got a really good clean RR interval. Now, one other tool that I wanted to mention, because we've covered quite a lot of ground, when you're collecting data live, you can use the media function to video your participants as well. So then you get the behavioral analysis as well as the physiological. I can't do that. I've only got one camera at the moment, and that camera is pointing at me, and it's tied to the webinar platform. But if I had multiple cameras, I can set those up, and when you start recording data, the video will be captured and time synchronized simultaneously. Okay, so I'm going to hand you back over to Brenda for our next poll.
Hi. All right, here we go with this poll, and I lots of great questions. I'm going to ask one of them right now from Trevor. Any differences between ECG data collected by the Ring and BIOPAC ECG units? Oh, I didn't launch the poll. Here you
Um, Not really. I mean, the big difference is, you've got one lead configuration, whereas with, one of our traditional um, amplifiers, you can pick and choose where you're placing your electrodes on the participant. That's an advantage for a typical leaded setup, but the Ring provides the phenomenal convenience of just putting something on a participant, one disposable electrode, and you can be up and running quite quickly. So in terms of the analysis, the analysis we've just run through HRV, you're going to get the same results whether you're using the Ring or you're using any of our other devices. So no significant differences other than if you really care about the lead configuration, electrode lead configuration.
Okay, awesome. Thank you. We have other questions that we will answer at the end. Let's just jump back into our presentation for right now, because I know we're going to go a little bit over here. And it looks like, okay, so 62% of people are using HRV in their research, with a 4% only saying no. So, oh, I almost hit the wrong button there. Okay, so thanks all for participating in that. Hugh, I am going to make you presenter now. And
Okay,
here you go.
great. And let's go back. So Brenda, how are we doing for time? Should I speed it up here so we have time for questions at the end?
Yeah, I mean, I think we can go till like 15 minutes after the hour,
Okay,
and then we'll just have to cut it off. And I've got any questions, just so you all know, any questions that we don't get to in the live Q&A at the end, we'll create a Q&A document, and we'll email it out to everyone. Okay.
great. So you can see my screen, Brenda?
Yep, we can.
Good. Great. So I'm going to talk a little bit about use cases, but before I do, I just wanted to show everyone the data screening feature we have when you upload your data to the SendStream cloud. And so as soon as you end a session, it automatically uploads if you've selected that feature rather than recording locally. And then you can go in, you can log in and select your particular session and display the data. And this is a very good feature for quickly screening um, your session. And again, you can display all of the channels, all the raw data, as well as the derived signals. And on this particular screen, I'm using this as an example. Here we're plotting heart rate because the peaks are being picked. In this case, we're not using the ECG data. Actually, this is a good screen. This is ECG recording with a traditional ring without the external electrode, and you can see the motion artifacts are apparent because it's hard to hold your other electrode, especially if you're engaged in other activities, and have a very motion-free signal. It's difficult. But I do like this particular feature here. This is the basis of heart rate variability. You're seeing the heart rate variation with respiration. This is an RSA indicator just by plotting heart rate in real time. And you can actually see the frequency modulation, in essence, of the IBIs with an inhalation here and then exhalation, inhalation. You can see the higher IBI frequencies, which is plotted here. Just wanted to show you that feature is that the derived signals are available for screening. And then this is an actual, just like Fraser showed in AcqKnowledge, this is an actual ECG channel where we've zoomed in a bit so we can check out the actual signal to noise ratio just by visualizing it. So let's move on to just some example use cases for everyone to review. For folks that are not familiar with the ring and are just tuning in for the first time, this is the fourth webinar we've done on featuring the ring. So just to remind people, in terms of real life uses, obviously an individual can record a session. Groups of people can record at the same time as in the same room, as well as a large group. And then, of course, people can log on worldwide and do sessions together that way. The data can be synced. When we started a year and a half ago, a lot of these use cases were theoretical, and now they're all being used by researchers. So classrooms, yes, grade school kids, high school kids have been recorded looking at classroom stress in some situations. One group actually sent rings home with students to record sessions at home in relation to what happens when they log on and get their test scores. One researcher was very interested in seeing how students reacted to seeing for the first time their test scores. Movie, TV, engagement, that is looking at EDA and HRV, emotional responses to different types of media. Dial down recording with meditation and mindfulness, using especially EDA to look at that. And now that ECG is available continuously, looking at HRV in those particular situations, just like Fraser demonstrated, using post analysis with AcqKnowledge. Workplace stress, again, in particular sessions, it's possible to record employee reactions to different situations. PTSD is of interest. I'm not sure anyone's actively looking at that right now, but we've discussed that use case with some researchers. Food and emotion also is something we've discussed. Emotional reactions to food, assessment for food manufacturers. Briefly, just want to mention that one of the things that continuous ECG recording makes possible is recording in active situations like this. Particularly of interest is monitoring driver stress. So this is a screenshot from a video we did a year and a half ago. This was in Goleta, right near BioPAC, where I drove around with a ring, and I, you can see this piece of duct tape here. What I've done is I've taped the iPad slightly at an angle to avoid reflection, and then the dash cam is recording the scene as well as the iPad. So this video is available on the BioPAC website. You can get the link and look at the whole video. The of interest here is even driving in a situation that's not in traffic. Driving is stressful, and it's interesting to watch this video, the change in the electrodermal activity, even with minor encounters like a car coming in the opposite direction. We're all very sensitive emotionally, and I think that in a way it's very useful to know how stressful driving can actually be. So that's an area that some researchers are interested in pursuing. Now that ECG is available, that will add the HRV component to it. And finally, I just wanted to mention another area we're interested in continuous ECG monitoring as well as EDA is sleep at night, wearing the ring at night, and then monitoring various vital signs during sleep. It's a really interesting area for research. And of course, you can go to a clinic and have a whole PSG study done that's expensive and not comfortable. If any of you have been to a sleep clinic and had that done, I've done several just to test out my own technology, and you never sleep naturally in that situation. So just wanted to mention that the ring now with this ECG capability makes it possible to do multi-channel monitoring at night conveniently. So that's what I have, Brenda. So we have a number 4 poll, yes?
Yes, I'm over here trying to answer questions. We do have a fourth poll. I will go ahead and launch that now. Whew. Which signals do you record? And then let me see what I can answer live here while that is going. Let me just do some filtering. There's so many questions I have to do filtering. So
Mm-hmm.
okay. So here's one question for you, Hugh, or maybe Fraser if he wants to jump in too. But for situations where the participant is remote and study staff is not in the same room, is there a simplified version of the app that will let the participant start and stop a recording?
Yeah, the app is very simple to do that. As a researcher, I would practice with the person in person ideally, but remotely you can practice using the app how to start and stop it and make sure that the data uploads properly to the cloud, and then look at it, screen it. So yeah, it's very easy to use, and especially it's designed for that for ease of use.
Okay. So thank you all. We will answer a few more questions, but we have had an enormous number of questions. So and David, I am going to get to your question in a minute, so just hang on. We there will be a question and answer document that we'll put together over the next couple of weeks. So give us time to like download all the questions and answer everything, and then we'll send that out to everyone. I'll end the poll. Which signals do you record? It was primarily, so the highest number is ECG, 85%. EDA is 56%, followed by a tie for PPG and accelerometry, and then um, temp is the 39%. So I'm going to go ahead and end this poll. Thank you all for participating in the polls. Love that. Now let me get over to my screen because I have a couple things that I want to show you. So thank you guys for putting the presentation together. It was awesome. Great job. I want to just tell everyone that we host workshops in your local region. So we have webinars, of course, that we do monthly. And then also, if there's something that you would like to see, you can invite people from your institution or your regional area. We can host a workshop. We can bring equipment to you. It's a great way to get hands-on experience with the equipment. Also, it can be like a half day or a whole day or even multiple days. So that's an awesome way to utilize our staff and bring equipment to you. And you can invite your colleagues. Yeah, we have live webinars every month. We do occasionally have researchers reach out to us and ask if they can present on some of their technology or research. So feel free to reach out to us if you're interested in that. You can just, contact your local sales representative. Here on our webinars page, you'll see that we have over 120 webinars, including the other Ring webinars that Hugh mentioned. So we've done 4 now, and you can just scroll and click on any of these webinars for any of the signals or equipment and watch them at your convenience. Back to the PowerPoint. All right, now on to our Q&A. So let me get all that information organized. So let's see, okay, here's a great question, Yoko. How practical is the ring? It looks bigger than the commercial rings that are out there. Can a participant use it for a long duration, say a couple of months or, overnight? You talked about the sleep study. Is there a function to mark events on the mobile phone?
Yes, the app has event markers you can insert, and those show up in the file. Oh, I think I didn't mention that, or maybe I did. When you log a session and it goes to the SendStream cloud, when you download it, it's in the form of a zipped folder with 18 different CSV files. And those are all the raw data as well as all the derived signals. So, and the event markers are there in the timeline.
That's the zip file is the session file that I opened up in
Hmm.
there. So I didn't expand it outside, but AcqKnowledge just unzips it, grabs the files it needs, and then just displays the data. But the other point, yeah, the ring is a little bit larger, but part of that is to try and maximize the battery life.
Hmm.
Um, the part that I would say would be considered, you would care about when you're wearing a ring is not such a big deal because the big part is above the finger, whereas the part beneath, particularly if you're not using the ECG, this part here is actually quite small and it doesn't hinder you from doing anything. Certainly, as Hugh demonstrated previously, driving and lots of activities like that, typing, using the phone, general run of the mill things that we all do. There's, no reason for it to cause problems.
Okay, sorry, I'm just like reading through all these questions. All right, David, I'm going to get to your question. I know that you had asked this in the registration uh, flow as well. So, okay, so what about pulse wave velocity and measuring via ECG and pulse signals? Can you guys address that?
Sure. Yeah. As I pointed out, you can get a pulse transit time or pulse arrival time. That actually, the app calculates that in real time. And we didn't display that though in showing the real time app. So if you know the distance between the heart and your wherever you're monitoring the pulse, then you could calculate velocity. But generally, users are interested in pulse transit time. It correlates, I didn't mention this, it correlates to blood pressure. So, this is one of the interesting uses for it in a continuous situation.
Yeah, and I mean, you can do that in that analysis in AcqKnowledge. You can
Oh,
put
yeah.
event
Yes.
marks
Yep.
on the QRS. You can put event marks on the peak of the pulse waveform, and then it will calculate the distance. There is a full application note on our website that guides you through that process. So, yeah, it's relatively straightforward to do that.
Okay, so many good questions. I'm proud of you guys, all the attendees who are asking such great questions.
Great.
Okay, so here's one from Osnot. I don't know if I said that right. Is it possible to sync the data with behavioral observations?
That's with the video camera. So if you're doing in lab and you're using AcqKnowledge, you can use either multi-camera or single camera USB style webcam, and then the physiological data that's captured via the ring is synchronized with the video. And then when you play back, you can jump to a part of the video recording and it will place the cursor at the corresponding time point in the physiological data, or vice versa. You can jump to sort of an activity or an event mark that you've put in there or something of interest in the physiological data, place the cursor at that point and it will advance the video to the corresponding point. Now, you can also do this remotely. One way to do that is to rely on the event marker and hold the ring and hand in front of the camera. You can shake the ring at the beginning. That will give you 3 channels of signal on the XYZ accelerometer, and you can use that to synchronize the corresponding point in the video recording, because as long as the shaking of the hand occurs in view of the video, you'll know precisely when those 2 events occurred, and you can time synchronize that. You can then bring the video data and the ring data into AcqKnowledge and synchronize it within AcqKnowledge. So either way around you can do it. Just depends on what your use case is.
Okay, and I'm just going to ask this one last question. I know we're like way over and we're even past the overage time. So, did you talk about battery life? A few people just asked questions about battery life and how long it can record for.
Yeah, it was in one of the slides. It's
Mhm.
approximately 10 hours of continuous streaming, and I think that's relatively conservative as well, Hugh, right?
Yeah, right. And mind you, this is HD data. This is people ask, well, what's the difference between this ring and like Aura? And none of those devices, Apple Watch, none of those devices stream data. They record and then upload little metrics. So yes, streaming data in multiple channels like we do is very taxing on BLE and the battery. So it actually does quite well to go for 10 hours continuously on all channels streaming.
And you're
Okay, and
getting all
then
the data, the raw data as
Right,
well. I
raw
mean, we
data.
kind of hopefully that was apparent when I was giving the demonstrations and Hugh was demonstrating the system, but you get access to everything.
Hmm.
yeah, so since you brought up data, there was a couple questions about, so you can stream the data live into the phone and into AcqKnowledge, right? You can
Hmm.
also download the data and then upload it to AcqKnowledge or some other system, like if you're using MATLAB or something. Are there other
Hmm.
ways to deal with the data? Did I capture it all correctly?
Yeah, I think
But
that covers the
uh,
Okay, yeah, okay.
all the options.
You
Yeah.
can download the data from the phone too, or do you have to get it into AcqKnowledge and then download it
You can upload it at the end of a session to the cloud. You
to the
can
cloud?
store it locally. You can store it locally on your phone and then email it or use some other app to send it somewhere else. And there's also a feature that you can uh, send to your own server. Like this was all meant for security. Like if you didn't if you're in some situation where your employer, for instance, prohibits you, like the U.S. military, from connecting to someone else's network, you can record locally and then store locally.
Okay, so hopefully that was clear because there were a lot of questions about that. So stream live to the phone, to AcqKnowledge, download, keep the data on the phone and send it, upload it, pass it on to your network somehow or another, or send it to your laptop and then upload it to AcqKnowledge if you need to do it that way or some other program. Okay, yes, we did it. It is 9:23 my time. Let us move on to the closing comments. Again, thank you to Hugh and Fraser for all the work you did to put into this presentation and for creating this great product. Awesome. Great job, guys. Today's webinar was recorded We'll email you a link to the recording, the slides, and the question and answer document that we'll put together for you over the next couple of weeks. When you close the GoToWebinar window, you'll see a survey. Please complete that so we can see your feedback and ideas. I'm seeing lots of kudos from our audience. Hopefully you guys can see that as well. Thank you all for participating, by the way. And so, yeah, so also please visit biopac.com. There's lots of great resources on there. Screencasts on specific features, overviews of signals and application areas, information about analysis tools, application notes with step-by-step instructions, software manuals, hardware manuals. There's a really robust site with lots of great information. Of course, there's information on our upcoming webinars, past upcoming events, and past webinars. Speakers, anything else before we conclude?
I think we're good.
No, I think we covered a lot of ground.
Thanks, Brenda.
All right.
Thanks, Fraser.
Yeah, thanks you. Appreciate it. Thanks, Brenda.
Okay, and thanks to the audience for being so engaged. Appreciate all the questions that you gave. Sorry we couldn't answer them all, but we'll follow up with you directly. This concludes today's webinar. Have a great rest of your day, everyone. Bye.
Great.
Thanks, guys.
Thanks,
Bye.
folks.